Good day everyone, I'm Jancyrus P. Cabresos from BS Ed Math 3B, and I'll be the reporter for the testing the difference between two means of independent samples using the t-test. In section 9-1, the z-test was used to test the difference between two means when the population standard deviations were known and the variables were normally or approximately normally distributed, or when both sample sizes were greater than or equal to 30. In many situations, however, these conditions cannot be met. This is, the population standard deviations are not known. In these cases, a t-test is used to test the difference between means and the two samples are independent and when the samples are taken from two normally or approximately normally distributed populations. Samples are independent samples when they are not related. Formula for the t-test, for testing the difference between two means of independent samples, we have the t is equal to sample mean 1, open close parenthesis, sample mean 1 minus sample mean 2 minus open and close parenthesis, population mean 1 minus population mean 2 all over the square root of variance of sample 1 all over the sample size 1 plus the variance of sample 2 all over the sample size 2 follows the format of, that is, the test value is equal to observed value minus the expected value all over the standard error. When the sample mean 1 and sample mean 2 is observed, is the observed between the observed difference between sample means and where the expected value of population mean 1 minus the population mean 2 is equal to 0, when no difference between population means is hypothesized. The denominator is the standard error of the difference between two means, and since the mathematical derivation of the standard error is somewhat complicated, it will be omitted here. When variances are assumed to be unequal, uh, we will use t is sample mean 1, open and close parenthesis, sample mean 1 minus sample mean 2 minus the open and close parenthesis, population mean 1 minus population mean 2 all over the square root of variance of sample 1 all over sample size 1 plus variance of sample 2 all over sample size 2, where the degrees of freedom are equal to the smaller of sample size 1 minus 1 or the sample size 2 minus 1. We have the example 9-4, farm sizes. The average size of a farm in Indiana County, Pennsylvania is 191 acres. The average size of a farm in a Greene County, Pennsylvania is 199 acres. Assume the data were obtained from two samples with standard deviations of 38 and 12 acres respectively, and sample sizes of 8 and 10 respectively. Can it be concluded at a 0.05 that the average size of farms in the two counties is different? Assume the populations are normally distributed. So first, for the solution, let's write down our given. We have the sample mean 1 should be equal to 191. Our sample mean 2 is equal to 191. Our population mean 1 minus population mean 2 is equal to 0. And the variance of sample 1 is equal to 38. And the variance of sample 2 is equal to 12. And sample size 1 is equal to 8. And the sample size 2 is equal to 10. For the solution, step 1, state the hypothesis and identify the claim for the means. Our null hypothesis states that population mean 1 should equal to population mean 2. And our alternative hypothesis claims that our population mean 1 is not equal to population mean 2. And find the critical values since the t-test is a two-tailed and our alpha is equal to 0.05. And since the variances are unequal, the degrees of freedom are the smaller of sample size 1 minus 1 or the sample size 2 minus 1. In this case, the degree of freedom is equal to 8 minus 1 is equal to 7. Hence, the table F, the critical values are, you have the 0.05 alpha, where 2 tails, and the degrees of freedom of 7. We have the critical values positive and negative 2.365. That's 2.365. Then for the step 3, compute the test values. Since the variances are unequal, use the first formula. T is equal to sample mean 1, open and close parentheses, sample mean 1 minus sample mean 2, minus open and close parentheses, population mean 1 minus population mean 2, all over the square root of variance of the sample 1 all over the sample size 1 plus the variance of the sample 2 all over the sample size 2, which is equal to 191 minus 199 minus 0 all over the square root of 38 squared all over 8 plus 12 squared all over 10. That is equal to negative 0.57. And step 4, make the decision. Do not reject the null hypothesis since negative 0.57 is greater than negative 2.365. Then since we summarize the results, there is not enough evidence to support the claim that the average size of the farms is different, since negative 0.57 doesn't fall on our critical values. Then, when raw data are given in an exercise, use your calculator or the formulas in Chapter 3 to find the means and variances of the data sets. Then follow the procedures shown in this section to test the hypothesis. For the confidence intervals can also be found for the difference between two means. With this formula, sample mean, open close and parentheses, sample mean 1 minus sample mean 2 minus t alpha over 2 square root of variance of sample 1 all over the sample size 1 plus variance of sample 2 all over the sample size 2 is less than population mean 1 minus the population mean 2 is less than, open and close parentheses, sample mean 1 minus the sample mean 2 plus the t alpha over 2 and the square root of variance of sample 1 all over the sample size 1 plus the variance of sample 2 all over the sample size 2, with the degrees of freedom is equal to smaller value of sample size 1 minus 1 or the sample size 2 minus 1. We have the example 9-5. Find the 95% confidence interval for the data in example 9-4. So for the solution, let's write down our given again. We have the sample mean 1 is equal to 191. The sample mean 2 is equal to 199. The t alpha all over 2 is equal to 2.365. And the population mean 1 minus the population mean 2 is equal to 0. Our variance for sample 1 is equal to 38, and the variance for sample 2 is equal to 12. And our sample size 1 is equal to 8, and sample size 2 is equal to 10. For the solution, we just substitute the formula. We will have sample size mean 1 minus sample mean some open close parenthesis sample mean 1 minus sample mean 2 minus the t alpha over 2 square root of variance of the sample 1 all over the sample size 1 plus the variance of sample 2 all over the sample size 2 is less than population mean 1 minus the population mean 2 is less than open and close parenthesis sample mean 1 minus the sample mean 2 plus the t alpha over 2 square root of variance of sample 1 all over the sample size 1 plus the variance of sample 2 all over the sample size 2, which is 191 minus 199 minus 2.365 square root of 38 squared all over 8 plus 12 squared all over 10 is less than the population mean 1 minus the population mean 2 less than open and close parenthesis 191 minus 199 plus 2.365 square root of 38 squared all over 8 plus 12 squared all over 10, which is equal to negative 41.02 less than population mean 1 minus population mean 2 less than the 25.02. And since the 0 is contained in the interval, the decision is to not reject the null hypothesis. Population mean 1 is equal to population mean 2. In many statistical software packages, a different method is used to compute the degrees of freedom for this t-test. They are determined by the formula degrees of freedom is equal to variance of sample size 1 all over the sample size 1 plus the variance of the sample size 2 all over the sample size 2 squared all over variance of sample 1 all over the sample size 1 squared over the sample size 1 minus 1 plus the variance of sample 2 all over the sample size 2 squared all over the sample size 2 minus 1. But this formula will not be used in this chapter. There are actually two different options for the use of t-test. Option 1 is used when the variances of the populations are not equal, and the other option is used when the variances are equal. To determine whether two sample variances are equal, the researcher can use a f-test or as shown in section 9-5. When the variances are assumed to be equal, the formula is used. T is equal to open and close parenthesis sample mean 1 minus the sample mean 2 minus open and close parenthesis population mean 1 minus the population mean 2 all over the square root of open and close parenthesis sample size 1 minus 1 multiplied by the sample size variance of sample 1 plus the open close parenthesis of sample size 2 minus 1 multiplied by the variance of the sample 2 all over sample size 1 plus sample size 2 minus 2 square root of 1 over sample size 1 plus the 1 over sample size 2 follows the format of test value is equal to observed value minus the expected value all over the standard error. For the numerator, the terms are the same as in the previously given formula. However, a note of explanation is needed for the denominator of the second test, statistic. Since both populations are assumed to have the same variance, the standard error is computed with what is called a pooled estimate of the variance. A pooled estimate of the variance is a weighted average of the variance using the two sample variances and the degrees of freedom of each variance as the weights. Again, Since the algebraic derivation of the standard error is somewhat complicated, it is omitted. Note, however, that not all statisticians are in agreement about using the f-test before using the t-test. Some believe that conducting the f and t-test at the same level of significance will change the overall level of significance of the t-test. The reasons are beyond the scope of this textbook. Because of this, we will assume that the standard deviation 1 is not equal to standard deviation 2 in this textbook. Well, that's all. I hope you learned something. Thank you for watching.